Hello everyone. Thank you for voting for new topics in the Telegram channel. And the topic that got the most votes there was hybrid cancer systems. But to understand hybrid cancer systems, you first need to know what a cancer system and a cancer agent are. And in this video, I wanted to talk about that. What is a cancer system and what is a cancer agent? What is the difference and when and how to use them? Let's take a look. So first, I'd like to ask you to watch this video. Simple memory in neural networks. How the simplest way to add memory to an agent. And after that, continue watching this. Well, in this video, we'll touch on it a little, but to understand it in more detail, watch that one first. So what do we have? Actually, there are several types of data that are used in automation and with its agents. There's the relational database. A relational database is like Postgres, MySQL, or Supabase. A vector database is a bit different. That's Pinecone, Quadrant, and there are also hybrid databases. That is, it's the combined use of these two. So I've highlighted these two. Why? Why combine them? Because a relational database handles tabular data perfectly. That is, when you have something like a Google Sheet or Excel format. So you can store relationships between tables, for example. It's the ideal option. A vector database, on the other hand, is perfect for text data. So if you put, for example, a table, an Excel table, for instance, into a vector database, then there might be a problem for the agent, for example, to calculate certain things. And that's exactly when a hybrid database is used, which is a special kind of database, when you need to use both text format in automation and also work with or manipulate tabular data. So when you need to calculate something in a table, the best choice is a hybrid database. All right. I hope you've already watched the video I recommended at the beginning of this one about AI memory. If you have, then you already know this structure. So we had it connected here in this way. This is the simplest memory method for an NN agent. You connect this node and it stores the context window, which is specified by this number here. Here I connected an external Postgres database created separately, and now it stores all the conversations not in the internal NN but in the external database. Let's try to write something. Hi, what's up? What time is it? Let's ask, what time is it in London? So I can't access the current time because I don't have access to the internet. Yeah. Okay, all right. Now let's take a look at the database. All right, I'm refreshing the page just to be sure, and let's together see if we can find our conversation again. Can I zoom in like this? I can? Great. And here it is. Here's our session ID. Yes. And what he answered me, this is what I asked it. So type human, type AI. What time is it in London? And it replied, hi, I can't check. So in this way, you can save all your conversations with AI agents in your own external database. So we've covered the basics of working with a relational database. I showed an example of how to connect it to an AI agent, but for more details on how to connect PostgreSQL itself, for example, and use it simply as a relational database, instead of storing everything in Google Sheets or Google Drive documents, you can check out my video called Another Connection, PostgreSQL and MySQL. There, you'll find a detailed explanation of how to connect and retrieve data from it. But we're here to talk about vector databases. Let's take a look. First, you'll need to go to pinecone.io. I'll leave a link in the description. Create a free account and set up a free index. In this case, it allows you to create 2 free indexes. You can think of indexes as separate projects or individual databases. And within each index, you can go in and see what exactly a vector database is. So if we open one of them, they're called chunks, or sometimes referred to as records, which are essentially segments of data. If we open one of these records, for example, you can take a closer look at its contents and see exactly what kind of information is stored inside. So there is the text itself, and then some additional metadata. You can add metadata manually, and it's essential to include it. We'll go through this with an example in a moment. And here is the actual vector. So if I copy it, for example, and then paste it, for instance, right here, just paste it in, yes. So I copied it, opened the console and paste it here. There you go. This is the vector database, meaning these are the vector data, which are stored in the vector database. And you'll be surprised, this is the ideal data format for an AI agent. It can instantly understand what it needs. So the text on the left, yes, it was transformed into these vectors. This is a vector database. Let me repeat. You can just take note of that. Okay, let's see what else is here. There's also a namespace here. As for namespaces, you can treat them, for example, as separate documents or separate subprojects. That is, each namespace has its own vector data. And when we make a request a bit later, you'll see that the namespace is very important. You can specify a particular namespace, and then it will know exactly where to go and what to look for. So before we move on to an example of how to build a RAG system with a RAG agent, let's look at the difference between a RAG system and a RAG agent. In this case, the RAG system consists of two components: a vector database, we already know what a vector database is, and some LLM model that independently decides which data it needs from the namespace we've provided or from the index, and in what format to respond to the user. So a RAG system is made up of two components. If we move on to a RAG agent consists of and includes a vector database, just like in a RAG system, and an LLM, also like in a RAG system. And importantly, a memory component is added to the agent. So in addition to using the vector database, we also make sure to add a memory component in order to store some additional relevant information that might be needed later on. This helps us keep track of more details and improves the overall system. Usually, it is primarily used so that, as I mentioned earlier, the system can effectively remember, for example, various dialogues and conversations with the user. This is very important, yes. So when a user asks, "What's the weather like in London?" and the next time, for example, the system can recall what the weather in London was. And then the user might, for example, ask the next question, "And in New York?" And if there is no maintenance and preservation of the link between the user and the conversation session, the agent will have absolutely no way of understanding what is meant by "in New York." Thus, memory is used to store dialogues. For example, this is an example of storing dialogues for user correspondence. That is, you don't need to put this into a vector database because a vector database is not designed for accuracy, but rather for speed and better interaction with LLMs. That's why you also shouldn't store numbers there that you might later ask it to calculate, because it will most likely calculate them incorrectly. And for this, hybrid systems will be used. But we'll discuss hybrid systems in the next video when we cover RAG agents. Now let's look at an example. So to show you a clear example of how this works, I pulled a piece of code from a real workflow to make it more understandable and visual for you. The task is for a binary file to be received as input at this node. In this case, either we insert some text and convert it into a binary file, or we prepare and upload a file through a form and provide it as input. Here we have a connection established, obviously a connection to the database system. Here, in this section, we insert documents. Here we select which index to use, and here we specifically specify which namespace is being referenced. You can also select the clear namespace option and enable it here. This means that every time you upload new files to this index and namespace, the previous files will be erased. By the way, this is the only way to update the data. For example, if you have a text document and some new text is added to it, or if a blog post is changed or updated in any way, the only way to update the vector file is to delete it and then re-upload it again, such as when you make edits or modifications. Keep this in mind when designing your code blocks. So be sure to connect the embedding model. In this case, it's the OpenAI text embedding 3 large model. Pay attention, the model here must match the model used when creating the index. So as you can see, the embedding model here is text embedding 3 large. This is very important. The dimensions must also match. Where is it specified here? So here we have the service and here is the dimension. In this case, it also absolutely must match. And batch size is the maximum number of documents it will handle or process in each request at one time. Now let's move on to this text splitter. There are also some very complex and important points here, you could say. Right now, I'm explaining the simplest way, just to make this video easier, because if you want to configure all of this manually, you'll need to spend a certain amount of time studying and setting it up. But in this case, in most situations, for example, if you don't want to optimize the system, it's usually more than sufficiently effective to simply use the approach that I am showing you here in most practical scenarios. Now, let's look at the default data loader. Let's take a look. Here, we specify the data type as binary, but you can also use JSON. Accordingly, if we specify JSON, then the input should be JSONs. So we load all the data, or you can select specific ones. So what do we have here? Automatically detect the data format. Okay. And metadata. Now we've come to metadata. Pay attention, metadata is a very important aspect when working with a vector database. Because we know that there's a namespace which will define a certain set of files, so to speak, that are stored under this namespace. But when you upload a file, make sure that you provide the correct metadata. With this metadata, in the future, you can, for example, find and delete only that specific file instead of erasing the entire namespace. You will be able to filter the data. Let me give you an example to make it clearer. All right. Let's say, for example, that you want to upload something. Let's scroll down a bit together. For instance, you might already have a certain namespace created and you want to upload, let's say, data that is specifically related to company documents, as well as data that is also related to company posts. So okay, this is our very first namespace right here, just as an example. And we'll be working with it. So if, for example, we didn't add the metadata correctly, then after we delete, or rather, if we want to update some of these documents, we'll have to erase everything and upload it all over again. And every time we use an LLM model, it usually costs money unless you're running it yourself, right? So every upload, every file retrieval costs money. And it turns out that if you have a huge batch of files with a large volume, then deleting and re-uploading them will cost a certain amount of money, depending on the number and size of the files. So, for example, if you add, say, for blog posts, the post date, which is the specific day the article was published, a brief summary of the post that gives readers a quick overview of its content, and the post title, which is the main heading or name of the article, then you'll be able to, for instance, easily find posts from a specific date and delete them just by searching for that date. This makes managing your blog content much more efficient and organized. Also, if you use a combined approach and store the post IDs somewhere, you can add a method to include the post ID and then delete only the post by its ID and reload just that one. This is absolutely necessary for optimizing your queries. The same applies to companies. If a company has documents related to it and you have a lot of them, you can mark them accordingly. For example, this might be related to accounting, legal, or some other department, and you can delete and update only that specific document. Let's get back to metadata. So here, for example, you have the file name metadata related to the creation of the file's creation date, and a detailed description. The description, for instance, could be some kind of summary. If the file is large, you can create a summary for the LLM model, and then based on the summary, for example, it can determine whether it needs this file. These are called chunks. So I hope everything is clear with this node. If anything is unclear, write in the comments. Subscribe to the channel. What videos I make depends on this. Also, join the Telegram channel and participate in the polls. This will influence the content that appears here, but it will still be related to automation and N8N. Now the last node here is chunk size. Chunk size, so it's clear that if we have a text document, for example, with 1,000 lines, we can split it in different ways. We can split it into chunks of 1,000 or into chunks of 5,000. The quality of the output will depend on this. 1,000, for example, is an optimal option. You can use that. But there are different strategies for different files. You can use various approaches, but here you need to test and see what works best for you. Chunk overlap is 0. This means that, for example, if you have, let's go back again, I'll draw it for you. Let's say we have one chunk and a second chunk. So each of them is 1,000, let's say. So these are, for example, 2 separate chunks. Together, that's a total of 2,000 in all. Okay, overlap. What this means is that if you have one chunk, then if you add here, for example, 50 or 100, then the next chunk will take some part from the previous chunk and load it with this new one. A little piece. This makes sense so that the model understands, yes, the order of these chunks. But at the initial stage, I would advise you not to do this because in any case, after making changes, you need to test and see how your modification works. Here, I've never used it. You can specify the file type, yes. If it's some kind of code, you can specify it. For example, HTML or Java or Markdown, but usually Markdown. In my videos, I try to give you the opportunity to figure things out on your own and to give you a fishing rod, a tool, so that you can develop your own workflows. Or are you more interested, for example, in making hype agents that look great in videos but don't work for real-world purposes? Please write in the comments. This is very important, because I realize that more people seem to want to watch ready-made workflows that look nice, but will they actually be useful for you? Because most of the workflows that are coming out in videos on YouTube channels right now are getting more views, but they simply don't provide any real meaningful value to people at all. What I want is to try to teach you in a way that you can develop and adapt them yourself and understand what each part is for and how it works. Please let me know in the comments. Thank you very much. Now, let's get back to the example. We've figured out how to upload data, so now let's see how to retrieve it from our RAG system to the vector database. Let's take a chat as an example. Here, we also have an agent connected, but yes, and here we have the Pinecone credential setup, as well as the retrieve documents function, just like we did previously for the agent. In this section, you can see that we have both the name and the description fields provided. Including these details is important for the agent because it needs to understand exactly what this particular node is intended for and how it should be used within the overall workflow. By specifying the name and description, we help the agent interpret the node's purpose and ensure it interacts with it correctly. And here I definitely specify the index. Limit is the number of chunks the agent can pull. At a time from the vector database, which can significantly affect the cost of interacting with this agent. At a time from the vector database, so this can really and created mesh data. This is that important part I mentioned. Yes, so that it returns this information with metadata, the information I talked about, Blue Iris database from the vector database. And the namespace is also important. In this case, brand brief is specified. And please, metadata filter. If you didn't add it in the previous step, metadata, then it will have to pull those data to figure out which pieces it needs. But if you specify the metadata correctly, you can, for example, tell the agent here that you need data and pass the dates for this date. For example, it will take the chunks that relate to this date. Again, if you specified the metadata correctly. And the second one is exactly the same. By the way, embedding module. The embedding module, just like when we load data, we need to specify the same one when we unload data. Because if you specify it incorrectly, the results may be poor. If we open it, here there is some information, in this case about the client. And let's go into the agent itself. Here there's just a brief explanation or description. Brand brief refers to the company and client refers to the client. Well, let's write something here and see what happens. Please give me the brand if you don't mind. Yes, of course. So it pulled up the company's brand brief. So we finally reached the end. I hope you enjoyed the video. This is one of the longest videos I've ever recorded for you. Let's see how you like it. It seemed to me to be very information dense. I did my best to explain to you what an RAC system is, what an RAC agent is, what a vector database is, and how it differs from a relational database. If you like this format, leave comments and give it a like. In the next upcoming video, we'll cover the detailed hybrid system. This is the most powerful tool for an agent.